Code of the streets. I was trying to find a way to think of that mixture of emotion and fear and frustration that a developer goes through as they learn how to work within the logic. Not so much the logic that they create, but learning how if statements, functions, for loops, how those things work, and how they return information and what they're returning them to. It's like, it's not a fair game to play, right? It feels like, why isn't this data arriving where you would expect it to be? Yeah, so just created something like this. Code of the streets, code of the streets. So, where we left off last video, it was a while ago. I mean, I don't know in real time. Couple days, definitely. And I haven't written the bubble sort once. I haven't thought about it. I've been working during the day, I'm coding at night or researching. I'm working on putting together a server right now for an application that I'm building. So this is the perfect scenario actually for you to see my progress, what memory I have of the concept of bubble sort, my Java syntax. All of it is bare. This is totally fresh. So you're gonna see this marvelous mind at work. How I think. You're gonna get to see it. No, this is probably about a week. So I really don't know if any of this is right. But I'm gonna check it later. I'm not gonna check it now. I don't have time. I want to get to the next major sorting algorithm. Bubble sort. Int. Numbers. Right? I know somewhere that's going to end. I know that there is a flag. Numbers sorted. Boolean. Numbers sorted, and it's declared but not initialized, and then there's a while loop here, so there's a do here. But I don't remember what the do. I don't remember how do works really. Yeah, do, and I guess a square, a bracket there. Yeah. And it's while. Numbers sorted. Right. So while that's true, that there were numbers sorted, do, and that do, so do doesn't have a condition. I gotta realize that. For int I starting at 0, I is less than or equal numbers dot length minus 1, I gets incremented, right? Yeah, that's interesting. For that time, Oh, no, 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 no. Yeah, yeah, no, 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 no. There's a condition that we're checking. There's a condition that we're checking in that number sorted array. And that condition is an if statement. If numbers position, oh, okay, no, yeah, for each element in the array, and then there's an if condition inside. There you go. This is the real reality of becoming a developer. This is what you go through. So I was right. Int I thought I was rushing, and in a sense I was, because I didn't really have a clear understanding. I is less than or equal to numbers dot length minus 1. I is incrementing, right, boom. For if numbers I, and what just slowed me up, if you're new, is that I realized I didn't have anything that was incrementing this value. So then I realized, oh, okay, the if statement must be inside of the for. In order to have that value change. So that's the correct structure of the bubble sort, which makes sense. But this is what you do as a developer as you memorize these processes. If numbers I at I is less than numbers I plus 1, int temp is assigned the value of number at I. Numbers at I no. It gets assigned the value of the number at I plus 1, the big number on the left, and then numbers at I plus 1 gets assigned the value, no, the numbers at I gets assigned the value of numbers at I plus 1. Yeah. No. And then numbers at I plus 1 gets assigned the value of what's in temp. And then numbers sorted is assigned the value of true. And that's the end of the if statement. if and for and do and last time I was confused as to whether this was a class or a variable, or a there you go, class or variable, or or would be an instance of a class, or if it was a method. The void tells me that it's a method that isn't returning anything. So this last one is the end of method bubble sort. So actually, like, I don't know if I got it right. I could do some tracing, and that's something else that I learned from another text that I'm going to pull from, is the concept of what we've been doing on the side is actually has a term called tracing. So for your Google search, you can use that term to describe when we start to flow through the code, mimicking the processor to check whether our algorithm is correct. Now, right now I'm just going to leave this because basically I think the algorithm is correct. And the purpose of this particular video isn't bubble sort. The value in coming back a week later, you know, and me learning Java, you know, I didn't really have a lot of Java in this last week because I've been researching an Express server. So to me, I think that's pretty good. I still need to work on my do while syntax. I'm still thinking do has a condition when it doesn't. While has the condition here. Do is the code block. But all in all, I'd say that's pretty good. So just the point of the video was that it's not a waste of time to memorize these things that you're gonna have to memorize in order to stand a chance at these interviews. Yep. And that's true of you, and that's true of me too. So the purpose of these videos is if you're new, to watch my growth as a developer as I move forward in the process of becoming a professional developer. And there's nobody documenting their whiteboarding algorithmic growth on YouTube. There's always some guy that's been doing this since he was like 6 years old, you know, running through some code and with callbacks and everything. You know, that doesn't help a person who wants to understand, can an average person do it? I'm a pretty average person. Went to the University of Baltimore, got a degree in information systems, technology management. Started a master's in computer science, and I got my butt kicked with an advanced algorithm and data structure course, where there was no introduction to the concept. I was slightly prepared because I had spent a year reading and looking at some of this stuff, but I wasn't ready. I didn't know Java. I left, started working as a programmer, and I really wasn't ready to program. I wasn't ready. I lost that job, and that was pretty hard. Then I spent the past 2 years, probably 2 hours a day on average, but probably more, quite honestly, closer to 3, I think, on average, writing code. JavaScript, full stack JavaScript. Now I'm switching over to Java for different reasons, or rather, I'm expanding. Now I realize I'm expanding into Java. Yeah, because you're always going to have to do some JavaScript. I'm looking at Bitcoins in the blockchain. That's all JavaScript. So the financial sector that I want to swing towards and that I want to swing you towards will require, definitely is going to require some JavaScript in the future. So I feel like I got prepared for that without really knowing it. But I'm learning the Java because I think that is the core of modern day programming. Don't worry about all the fancy talk about Python, okay? Get your black asses down and sit and learn some goddamn Java, right? That's what you need to do. What you need to do. Okay? It's a different culture for your competition. They want to know that you can code. Okay? You're not just a good kid. Okay? You don't have you might have a rich uncle, but most of us don't. So my goal is to get you guys where you need to go, and also Java because it's also the core of Android development. All that Kotlin talk, let some other people worry about that. Make sure you know Java. Java is the way for you to be able to do all this stuff, including web-enabled applications. Knowing about Tomcat. You need to know Java if you're going to get a chance at getting the real jobs that are going to get you the money. All of the people that are doing Java now, not all of them, but tons of people are leaving Java behind. That means those Java jobs and all their legacy code is going to be there. It's going to require maintenance and people that can maintain it, add more. They're not going to switch over to some new language because it's hip. That's where you start. And preferably working in the financial sector. Yeah. So that's a little bit about where we are now. Like I doing a couple videos and I'm starting to get an idea. I got a potty mouth. A little bit more about me. I was a hip hop artist, visual artist. So it influenced my take. My take on life and how I speak. What I'm gonna say. I'm from Baltimore. So that's going to influence things a little bit too. I'm not going to leave behind everything about me. I'm just going to bring it with you. The goal would be if somebody at IBM would just be like, oh yeah, he seems like a decent kid, and he's working hard. I like that. I like that. That's what you should like, right? It doesn't matter if I like Wu-Tang and you like Seinfeld, man. I like Seinfeld. That's what you may not know about me. Can I live? So let's get back to these algorithms. So this is perfect. So I'm just using this text for a second. I'm just borrowing the text. I hope, for the love of God, I hope a company wouldn't care. For the goals that I have, okay? Good God, okay? Black Lives Matter, please let me use the bubble sort and the insert sort from this text to talk to a few thousand, hopefully. That would be dope. Create a couple thousand programmers, coked up the streets, coked up the streets. Who's coked than me, coked than me. So the next one is, how would you implement the insert sort algorithm? So, once again, I haven't looked at this besides looking at it maybe like for 2 minutes, maybe about a week ago. I know where I stand with bubble sort, which is somewhat surprising to me that I was able to remember that much of it, that once I started writing it with my pen, the power of that connection of the hand, the mind, and the pen, and that's something that I'm trying to get you guys to feel, or the keyboard and the mind. But this is what you're going to be using in the whiteboarding interview, so you may as well get used to it. Once you start writing it, I've built some confidence now. Like, okay, I was away from this for a week, and I come back, and I still remember, and I remember the purpose of bubble sort, and I can tell you that bubble sort is when you have a collection of items, for each pair, in that collection, starting from the original position, you check if the object on the right is greater than, or object on the left is greater than the object on the right. And if it is, then you switch. And that the large ones start to sort. And you do that over and over and over until they're all arranged. And that's bubble sort. What they want you to know in algorithmic land is that that is highly inefficient, right? And I guess a different video will be about learning why it's highly inefficient, and big O notation, and time complexity and space complexity. These are other topics that I'm going to find a way to bring to you, right? Because you have to be able to describe. You have to understand how that relates to these algorithms. But right now, we're just working on the core. We're just working on knowing what the algorithm is. So then I say all that because the next one is insert sort. What is insert sort? What do I know right now about insert sort? Not much. I know that if we have an array, or some type of array-like object, we have a collection starting at 0, that to get a value in this array, you know, my array, let's say 4, it costs different amounts of computer processing time, and that the purpose of moving away from bubble sort, or using something other than bubble sort, and learning insert sort, and then learning quick sort or merge sort, is that there are, depending on the problem, there are very efficient ways to accomplish these goals. And you know, something that I'm thinking now, as I want to express to the person that's just beginning, is that you would think, but there's infinite problems, right? How are you, what's the point then? But there really aren't infinite problems. Or rather, there are infinite problems, but you won't be addressing most of them. You will be addressing the ones that are very well known, whose solutions exist. And you need to learn how to implement. And that's part of what we're learning now. So what I do know is that insert sort probably makes it less expensive. So let's say you have these numbers already in here. Or letters. So C, D, and let's say we screwed up, we hit them rocks, and you forgot what comes after D, so you kept singing the song F, G, H, J, I haven't done a K in a while, L, right? And so you realize you got to get an E in there to fix this. And how are you going to get that E in there? It's painful because you already did the work. If I wanted to insert an E in this in real life, I gotta find the eraser. I gotta carefully take time out to get these. I might have to redraw some of these lines just to put that E in, and then I have to write everything again afterwards. That's an expensive operation. What is that? 1, 2, 3, 4, 5, 6 spaces. And then I might think to myself, well, can I do it the other way? Can I erase these? But with this information, this is accurate already up to here. Maybe if these weren't, this was an alphabetical list, there might be a solution that way. But so what insert sort does, or what I think insert sort does, because I don't know yet. Yeah, I really don't. I could be wrong about that. Maybe that's not what insert sort is going to do, and that's another thing I got to keep an open mind. So I just know that somehow insert sort makes it less expensive to put items back in. This that I just made up using strings makes me think, oh wow, maybe insert sort is solves a completely unrelated collection of problems. But walking that edge and keeping my mind open, let's find out what insert does, or what insert sort actually is. Okay. So yeah, I'm gonna just let it ride. So they give you some pseudo code. So I'll be writing that down. And once we get her done, then we'll get her done. Given a list L and a new list in L, for each element, original list element in list L for each element, new list element in list NL. Okay, alright guys, it's an insert algorithm that seems a little inefficient from my first approach to it. It's hard to spell and talk at the same time. Original list element. New list element. One thing that's funny to me here is the pseudo code of this text. There is an obvious attempt to not use anything that resembles Java. So that's the pseudocode. Pseudocode, you know what I'm saying? You know what I'm saying? Look fugazi to me. Given a list L and a new list in L, right? So a list and a new list for each element, original list element in L, right? For each element, original list L element in list L. For each element, new list element in list NL. If, yeah, okay. Yeah, I don't. Yeah, so if original list L is less than new list element, if those index positions, right? Yeah, you're basically saying right here how we've been doing if L at I, if each one of those maps to a variable named original list elem, right? For even, and you compare that with NL going to each index position at new list elem. For each of those index positions, you're putting those in those values and variables, and you're comparing them. And if for each item on both of those lists chugging along, so like I said, you want to create models. So let's create a model. Let's just slow down. Paint a happy little array. How about that? Let's call this one L. Big L, you know? And let's call this one NL. Like I say, because of my vibe. But, because I'm being sensitive. Can't fake no more. Can't tell jokes when you got jokes. Motherfucker. You want to be human, amused, and write code? Alright, so we're just comparing the relationship for each one of these. See, and you know, that's the funny thing, right? Some people may not get what I'm saying, and then immediately the code just makes sense when I draw a model. You want to know, for each one, down the line, you're comparing original list item from list L in this position to the new list item. If original list item is less than the new list item in that position, insert original list item in NL before new list element. Else move to the next element. And if original list element has not been inserted previously, insert at the end of new list. At the end. Yeah. So I started creating a model, and I'm glad that I did, because I don't know what the hell's happening right now. So now that I already did the dirty work just by habit, it does make it easier for me to start to begin to say, well, if this is true, then what does that really mean? I don't know, because this isn't doing anything that I would think it should be doing. So then let's start to create a model of what, not what I think it should be doing, but let's create a model of what this says it is doing. So we'll start to learn how insert sort works. And see that moment right now, just then, when you saw me go from thinking I knew something and being ignorant to finding out the answer, in a sense of at least where to look. That is what the programmer does. And we do that over and over and over. And you start to get used to it. You think you know what's coming, and then you find out, no, that's not how it works at all. So let's find out how insert sort works. And this is telling me. See, this is different than someone saying, make a program that does this. The difference is, you can be a pretty decent programmer and make programs that do what they ask you to do, but you still don't know this kind of stuff. And if you don't know this stuff, you're not gonna get into the companies that you want to work for. You know, maybe you could start your own business. It's a whole other discussion. One that I'm not qualified to have. A little bit, but we'll talk about that, why. Right, but if you want one of those jobs, you want to work at the Googles, you want to work at the Facebooks, you want to work at the Instagrams, this is what everybody who works there has to go through. Right. It becomes a bubble in a bar of soap question, because most black applicants don't have an uncle who was a programmer, or an aunt who was a programmer, or a dad, or a mom, or a cousin. They don't have those things. They don't have somebody that introduced them to programming outside of going to college and starting. So they're fresh. And they don't even hear about this stuff. And then they go to the interview, and somebody's asking them how many bubbles are in a bar of soap. Right, and implement an insert sort. I will sip my coffee. Right? What are you gonna do? Right? You're sweating, and you're like, I passed all my classes. I know how to write code, and they're telling me I don't know something called insert sort, and that's why I don't get to work there. When I would be a valuable member of the team. That's how it goes, nigga. So learn insert sort now. That's what we're doing. So code of the streets. So then what do I need to do? I'm not talking to y'all to bring you in, but also get my ass in first, right? So I need to figure out how insert sort works. And so what I need to do is actually follow the steps of insert sort. For each element, original list, element in list L, right? For each element, new. So it sounds and it looks like we're going from one for loop to another for loop. So control the program is going to go into this nested for loop, right? So now we're actually talking, you can forget array L. You can think about this one. For NL, only thing you need to know is that we're going to, whatever we're doing to this list, NL, we're going to do it for each element for as long as L is. And we're going to do it as many times as there are elements in L. For each element new list elm in list NL, yeah. If original list elm is less than new list elm, insert original list elm in NL before new list element. So I don't really understand yet from those directions. But what I think I'm going to do is just create a random array. 3, 7, 4, 8, 5, 1, 6, 2, 9, 0. I think that actually uses all the numbers. Once I started writing it, I started thinking I wanted to 9, 0, and we'll get rid of 10. That's not what we're interested in here. So one of the first problems that I have with this description is that I could understand beginning to think, is new list? This description doesn't tell me if new list is empty, like this, or if it is a new list and it's filled with numbers. I'm not getting that from this algorithm for insert sort. I then assume that new list may be a list that is completely empty. And one of the problems that I have then is, because I don't know enough Java, is an empty list null, right? Why do I want to know that? Well, because that's going to affect trying to run the code. It may or may not in Java. I don't know. Do I initialize this or something? I don't know. So these are avenues that I need to go down in order to understand insert sort. Complexity which is increased by me doing this on tape. It's like defusing a bomb. So what am I going to look for? Maybe Java array empty list came up in and then that poses another question, because I know books tend to skip around or assume knowledge. This book is assuming knowledge of the Java language, and so then therefore if it's using language of insert sort, it's also using language of lists and list elements, list objects, and the assumption is that you know how to create lists or use those elements, array lists, the inheritance tree for those things. I don't know those things right now, not memorized. I understand that these questions exist and that they need to be at my fingertips. So that's something else that I learned here that I need to do some research on. But for the purpose of the whiteboarding memorization and understanding, you can gather that all at once, basically. And that also adds a little complexity to the query that I'm performing now of initializing an empty array. So there's a difference between having an array that has null or incorrect values and having a list and using the inserting algorithm of Java to insert elements into a list. That which is time complexity, I don't know what it is. That would probably be something else to think about. So the question is, am I asking the right question? Yeah. Does insert sort use an array or a list? That would be the question to ask. Does insert sort use an array. It looks like insertion sort builds a sorted array, but oh, you can use an array. Okay, and so while looking in to see if insertion sort uses a sorted array, now I'm seeing implementations of insertion sort in Java. Uses a different implementation. Yeah. But it seems as though it's doing something different than what I thought we would be working on when I first talked about the complexity of changing the value of the elements in that array I wrote up there. If an array, yes, so here's what there's one question that I need to ask, and that is, if an array is not initialized, can you compare what is in its index positions? So I need to find the answer to that question. So this is it. Yeah. This is when I'm. You're worried that this is boring, right? But you know what? So what? Like, don't watch it, right? Go somewhere else, right? Right. But what I'm doing is showing people what it is to be a programmer, right? An actual programmer, not a YouTube programmer, right? Somebody that's trying to become a programmer. Right? Yeah. Alright, that's dope, then. I'm good with that. I don't have the bottom of the board. Yeah. Alright. I think that'll hold. So then initialized array, Java. And so one thing I need to figure out how to do is how to show my Google search. I gotta figure out how to show my Google search to you guys, because holding this up isn't gonna help. It's just gonna be a blurry screen. What is the default initialization of an array in Java? That's what I got. That's a result for an article. Okay. That's great. So everything in a Java program not explicitly set to something by a programmer is initialized to a 0 value. For references, anything that holds an object, that is null. For int, short, byte, long, that is a 0. For float, double, that is a 0. Booleans, false. For a car, that is the null character. And forward or backslash u followed by 4 zeros. That's whose decimal equivalent is 0. When you create an array of something, all entries are also zeroed. Right. So, assuming that we are working with arrays and not lists, or for one, I would say that there could be two implementations potentially of an insert sort algorithm. One that uses the language-specific list objects of Java, and then the second that is more general to all programming languages that would use arrays within each language, maybe with certain tweaks, right? But we're dealing with Java. So then, if I am picking a path now, and assuming that we're dealing with arrays, in which case we can say that even if NL is empty, it's filled with zeros. Right. In which case we can begin the comparison process. If original list element is less than new list element, insert original list element in NL before new list element. Oh, okay. Alright, so I was finding this highly inefficient and broken because I was like, even if we do that, we're never gonna finish the entire list. But what I think I missed was the power of the nested loop to pin a check on each element in the new list element with each of these index positions. We're going to go check each and every one of these against 0, and then 1, the index position 1, and then the index 2, and then the index 3, for as long as L exists. And we're going to perform this instruction. So now I see a little bit more complexity in that insertion sort. I still don't quite get exactly how it works, but we're further in, right? Or I'm further in. And also now that I picked and decided that this is a list, or this is an array, and we're using primitive values, the complexity of that algorithm is decreased also. I mean, I guess this would just be, if this were objects, it'd be referencing memory locations. But then how would you'd have to use some sort of comparison in Java, something that, comparables, or something that can perform the comparison, right? Something else for me to to dig into. This is going to take a second, right? Right. I mean, in order to be rock solid in Java and move in that direction, yeah. And in the meantime, right, what do? So what do? Right? All these youngins want to run in. I build projects. I continue to build projects. I build a portfolio that's rock solid, right? Like when somebody opens it up, they look inside of it and they go, "What in the world? Like you built all these things?" Yeah, I built all those things. Yeah. And you're passing this whiteboarding exam. Why haven't you been hired before? Why aren't you successful? What have you been doing with your life, dude? Yeah. Well, sir, I'm from a Democrat-run hellhole. Oh, okay. Well, you're probably not the right fit for us, but good job. That's what I imagine. That's the problem. That's the problem, right? Right? Is whether you go through all the work, you do all the work, you got your proof on your paper, you're fucking brilliant. You came from a place where nobody comes from, and you're still not the right fit. I'm sorry, sir. But we only hire Yale here. Yeah. But you see, this is basically where we are now. So we've limited the scale of this, and now we have a method of attack, right? And so now, if original list item is less than new list item, if 3 is less than 0, is it? It is not. We're going to else move to the next element. And when they say next element, they mean for each element new list item, for each one of these in list NL. So we check, is 3 less than 0? No. So then we move to the next element. Element being the next element new list item in list NL. So boom, we're gonna finish. Right? 3 is gonna be checked against all of these. If original list element has not been inserted, insert at the end of new list. I'm starting to get the algorithm now. It's a funny algorithm. And it is highly inefficient. Yeah. But it'll work. Right. So, what do we have here? This becomes six, 7, 8, 9, 10. 4, 5, 6, 7, 8, 9, 10. That becomes 3. Insert at the end of NL. Right. And then we're going to leave this 4, and we go back to this 4 for each element, original list element in list L. So since that 4 went through one iteration of checking against 3 against all elements in here, we go over to here to 7, and we have to ask ourselves the same questions against this new array, not this one anymore. This is NL after one loop, after one 4. And we're going to ask ourselves, is 7 less than is 7 less than 0? Yeah, it's very well designed actually. And you're going to go through all of these and you're going to get to here. Is 7 less than 3? No. So then, if original list element has not been inserted, insert at the end of NL. So we finish the second for loop for this element. So we go here, 4. And we go through all of these zeros again, and then we get here. Is 4 less than 3? No. Is 4 less than 7? Aha! Yes. From the original list, 4 is less than new list element. So we're going to insert original list element in NL before new list element. So what does before mean? Now this statement right here, this is a hard statement. Because right there, this is what pseudocode is, and it's what's challenging about understanding how to program, is that what this line is describing is actually can be broken down into a subset of operations. Okay, so how do we insert original list item in NL before a new list item? If we just took it literally, we would insert 4 before new list item 7, and we'd put a 4 right there where the 3 is. But that doesn't capture the spirit of insert sort, which is that we want to keep both lists in their whole. We can't just remove 3 and put 4 there, right? We need a 3, a 4, and a 7. And so how we do this, that's going to be something that we implement in Java. Maybe similar to what we did in bubble sort, which is to store the value of 7, put the value of 4 where 7 was, and then put the value of 7 in that space, so that you are inserting this item in the list before new list element. This is a reference to the value. It's not the index position. Yeah, they're just saying this value, new list element, insert it before that value in the list. Insert original list element 4 before 7 in this list. If this said something like this, then you'd have a different problem. You'd be talking about the index position, and then insert that in original element, that value in that list before that particular position. But that's not what it's asking for. It's asking for before that value. That's just something that I just cleared up in my head just now while working out this problem. But it's something that, it's a step of understanding that you have to get here, or I have to get. It didn't just appear obvious to me. And so it's something that I think is worth mentioning. So I had to realize we're talking about variable values. And this insert is talking about inserting these elements by their value, right? And that value is stored in these variables, right? Right, and then there is a little hocus pocus here that actually involves nested code, like nested lines of code. And what is that code? That would be important to look at. Right now, I don't know if this is how they're going to handle it. I don't know exactly how they're going to handle it in the text, but what I would say, based off of what we've done recently, and this is very important, right? Just like people don't have the food touch. Chop your whiteboard up in the fields, okay? Especially when you're doing the problem solving. Make it neat. Section off what you were working on, okay? So that it makes sense to you later. But what I think is important would be, because I'm dodging it internally, so I know it's important, is to actually do that insert original list element in NL before new list element. So what does that mean? That means just what I said, that we would save that element, a new list element. What is its value here? It doesn't matter. New list element I. So let's say we would have a var variable named temp, and we're going to assign it the value of new NL for each element new list if original list element is less than new list element. Insert original list element in NL before new list element. We're in NL, so the index position that NL is at, I'm putting that in the temp variable, right? And then I'm storing let's not use var. People out there know that that's JavaScript, but I'm trying to create a pseudocode for it. So then just I don't know, val. Let's say val. I like that. So val, my data type, whatever, and stored in temp. And then I want the same switch. I want NLI to be assigned the value of original list element, right? And then I want NLI plus 1 to equal the value of temp. Now this solution doesn't account for when we're in the middle of the array and that condition is true. It only accounts for when we're at the end. If original list element is less than new list element, insert original list element into NL before new list element. You see, the problem is and maybe it's time to switch to a more complex list at this point. Yeah, I think it may be time to switch to a more complex list at this point. picture. And actually, I'm not erasing all of it. I'm just erasing maybe this. Yeah, we'll get rid of that. We'll get rid of this stuff. Yeah, no, this is a real day. I think this is the first real Code of the Streets video, huh? Where you start to see the process, right? So I'm an hour in. And, part of it is me talking. I gotta talk to you. Gotta explain exactly what's going on. So the reason I erased that is because we've already come further along in the past hour, much further along in our understanding of insertion sort, right? We see that it's a nested for loop, which is in squared time. I just know that. I still never really truly understood the difference in if you're talking, and I asked my teacher this, he just got mad. He didn't understand what I was asking him. Like, let's say this is in and this is in. Sure, you have the option to multiply them, right? And call this n squared, right? But as far as I'm concerned, that looks like n plus n just as easily, which is equal to 2n or n time. So there's a contradiction here. Which one is it? If I have nested for loops, right, I will wind up for each element added to the value of n with n squared iterations. But that n squared iterations in this may just be the size of n in a different problem. Well, that's true, yeah. It has to be a different problem, yeah. So maybe I'm answering my problem. Maybe I'm answering my question, right? So, some people out there, maybe somebody's going to write a comment that explains that to me. At some point, be 58 years old, like, that's what it meant. Hey, but that's the journey, right? Why not? Alright, so right now we're looking at this again, and what you want, right? What we're looking for, and why I erased that is because I need a new model, because my old model was used, and I needed to create a new space to think in. So you gotta do that sometimes, right? So I need for the old model had numbers that were there. This was all zeros, whereas these were always going to be larger. So let's change the framework. 4, 3, 7, 9, 2, 8, 1, 5, 0. I don't have 6. 6. There we go. Let's do that again. 2, 9, 1, 0, 8, 7, 5, 4, 3, 6 wound up at the end again. And that's just how the cookie crumbles, huh? So there you go. That's interesting in and of itself, right? Who knows what I may wind up with because 6 wound up in the end again. And that's reasonably close. I might want to tighten this up. Because I don't know if I'm gonna form a comparison between them or what. Now we're pretty much set up. We're gonna call this L. We're gonna call that NL. And now that I have space on my board, I'd actually like to trap that over here. Right. And we're going to perform the first comparison. So, what have we learned so far? We're starting to get an idea of how insert sort works, and some of the factors that are involved, right? You're not just dealing with one list, like bubble sort, you're dealing with 2 lists. And that's pretty clutch right there, just to think about, right? Like, if someone were to ask you about insert sort in an interview, immediately you should be thinking about 2 lists. And you should be wondering, like I was, are we talking about lists of instances of a class? Because in Java, you either are dealing with reference variables or you're dealing with primitives, right? So, are we talking about using an array? Is that array, or are we talking about using a list, which is a completely different structure? It seems as though that for this is a tough video. This is a long video, and just because there's a lot of paths that have to be navigated, forks in the road. But the next step in the book, and I know this, but you don't know it, and the next page literally walks you right and smack dab into some Java code, right? So I'll find out what it was, the structure is that they were implementing. We used an array. An array may not be the right structure, and this is part of what we were researching earlier, for this particular. It looks like online that you have people calling insertion sort with array implementations, but it could be that a true insertion sort does not use an array, implementation, or does not use a list implementation. We don't know yet, right? If I am to follow these rules and try to implement it using the laws that govern arrays that I know, it may or may not work. But it's worth a shot, I would say. Or it may not be, right? So in terms of time and what I want to accomplish, that's where you leave the theory behind. When you're in the workplace, you need to know if you're talking about array lists, arrays, what the collection element, what the collection item is. What is this box that's slicing these things off? What is it representing? Yeah. You see, like a collection is a bunch of little boxes, each of which could house any number of elements. 10, right? These could all be instances of a class, and each of them is held in a list, right? They are elements of a collection of elements, right? But they're not values dropped into this structure, this one particular structure, a particular object in the language, and that is important because of the sorting algorithms that the language itself may use to handle how insertion takes place. And that's what we've been wrestling with this video. So at this point, I would say, since this is a video that focuses on prepping a person for using Java, then we're going to look to see what the Java implementation is. Yes. And so our work was definitely rewarded. Yeah. The reason that I say our work was rewarded is because this text and where it's shepherding us to go is to understand the implementation, not with an array, but with the use of the Java language and the libraries that Java holds. So it's more so, we covered the basics, we covered the raw stuff, and what you need to know as a programmer is that when you see the language, the methods of a language being used in this algorithmic way, it's different. It's a different way of sorting than you would be trying to use insert sort using raw arrays. So already think about this. You need to know this way, and it would benefit me to know that way. It would benefit me to know that way as a programmer, to implement my own insert sort using arrays. That would be a nice thing to do, you know. But when we're talking about the cache and moving towards the cream, what they want you to know isn't. They want you to know what we had in that little box there when we did the sorting, creating a temp variable and performing the sort. That you can pass data. That's pretty low level. But what we're learning here from this text is to be prepared for the use of the Java language. And in the job, they don't want you figuring out sorting algorithms, right? Right? That's a trick. That's a track code. Yeah, they don't want you sitting there figuring out your own. That's not going to help anybody. They want you to get the work sorted. So in the same way, what we're about to do now is to follow the path of the text and make the jump for insert sort using some of the structures of the Java language. But I think what we would take away from this is that insert sort, when you hear insert sort, think two lists, right? Think two lists, and think nested for loop with some if statements, and also this right here, if it has not been inserted, there's two if statements. This one matches up, and one is a nested if statement, and one is a peer to the nested for loop. So think about that structure, right? And try to lock that into your brain, that there's a nested for loop. The inner for loop has an if statement. The outer for loop has a peer, a sibling, in terms of code, the direction that the code is going to go, right? And that is an if statement, the second if statement. That if statement adds an element to the back of the list if there's nowhere else to put it in the middle, right? Essentially, it would grow the list, or it would say this is the largest element that we've seen so far. Yeah. So then what do we do? Well, at this point now, I'd say we don't need to grab any of that. It was worth our time to erase and rewrite because we realized, and this is just something to know about the language, is that hocus pocus, or we were still faced with the problem of how we would perform this in a practical level, which would require that we move. If we were to start here, you would eventually get to a place where an original list item, we find 9, we find 4 is less than 9, correct? So then what do? We could store 9 in a temporary variable. You could create a temp and store NL I in there. Let's say temp is equal to 9. Right. Is equal to 9. Now temp is equal to 9. Or no, now temp. Oh no, that's true. NL. Now NL at I is equal to L at I. And not quite at I. And actually, see, it gets a little tricky. It gets a little tricky. Let's say NI at J. Right? It's a little more complex than I want to get into right now, but let's say at J. Li is equal to NI at J. Right? And then we could take the value 9 and replace it with 4 like we just did. Let's not go down that road because I don't have the time. But the problem becomes, and let's just turn it into words. Because it's not worth it right now. The problem becomes, if you replace the 4 here, then the 9 you still have in storage, but you want to put the 9 here, but then you got to put the 1 in storage. And if you put the 1 in storage to put the 9 here, and you can put the 1 here, and you still got to put the 0 in storage, right? So there's going to have to be a nested loop inside of there almost, or like you're going to have to keep putting those values in storage for each index position 1 higher in NL. So every time you're going to rewrite the whole list, and then you might add something at the end. Or you're going to add what's in the list at the end, yeah. That's the problem with the implementation of insert sort as an array. Or that is not the problem, but that is the problem. That is part of the solution. But we're not doing that right now. Okay, we're not, because you aren't going to be asked in a Java interview to implement an insert without using the Java, or you may not. If you had to implement an insert sort using none of the methods of the language, that's a pretty challenging question, right? That's not something that you would normally get asked in an interview. You might. Right, right. But that's a different question than implementing insert sort. Right. Those are two different questions. Implementing an insert sort using none of um, the methods of the language, so that your bare bones basically is a different problem than implementing insert sort, and that answers part of the question that we were dealing with earlier. And implementing insert sort in Java, right? That's even a third question, you could argue. So we're implementing an insert sort in the Java programming language. Code of the streets, code of the streets. And this is what we're going through. We're at 131. Okay, it's not bad, right? I mean, if you think of me studying while I'm in university, you know, and you add some more time. Let's add some more time for the jib jab. You know, and you get a feel for, you know, whether I'm qualified for this or not, right? And what my analysis is. Why I'm performing the analysis that I'm performing. How fast is my mind moving? These are the things they want to see. I don't know if I'm qualified for it. I just know I'm gonna do it. Right? I'm just not gonna be stopped. We ain't going nowhere. We ain't going nowhere. Well, my P. Diddy dance, man. I might have to hurt y'all. Alright, so we're doing the insert sort implementation using Java. This is the purpose of this particular text. So let's put that up. And we can go forward knowing that we do know pretty much all the details, but I think we're going to learn a little bit more in this implementation about the Java programming language itself. And this is kind of verbose. I think I need to shrink this. Yeah. It's a little big for this. Static list. This is these are generics, is what I've learned, and you can have where you pin down the type of a method or a class. Something specific to the Java language. Look, I'm not a Java programmer. I'm trying to become one. Or someone who has Java in his arsenal. Just a reminder. Quite as straight as I like, but we want to ride with that. But we can go and straighten it out here. Final list. Integer sorted list. List. Original list. Okay, they're throwing it all in, huh? Original list. integer number. Numbers. Four. And 0. Less than sorted list dot size. Number plus sorted list dot get I sorted list dot add. Continue. Original list. Haven't seen it continue in a while. Sorted list dot add. Sorted list dot size number. Return sorted list. Reminder. I think I'm gonna send you a reminder. Oh. Reminder. Reminder. Oh. Yeah, that looks accurate to me. Alright, code of the streets, code of the streets, code of the me, code of the me. That looks pretty good, right? Yeah. So what do we have to do, right? Like, so I mean, basically from the position that I am in as a Java developer, what do I understand about this? That's a pretty interesting question, actually. To have to face that on film too is interesting. Yeah. Yeah. I got my balls on the fucking table over here. My life is on the goddamn line. Forget about it. That's not a way into the Fortune 500 talking about your balls. No, but I think, come on, man. How you not gonna cut a break for a brother? Come on, man. I'm from the hood, man. Everybody want to talk about, they want to help people. They want to give donations, or people want to give away billions to companies that'll never trickle down that money. Please, help me, okay? I'm a normal goddamn person. Hey, yeah, it's crazy out here, right? Public static. So, what do I know about this? Now, yeah, there's been some growth, right? Yeah, exactly. So this is public. I'm gonna say this definitely is a method, right? Because it is a method of the class that's denoted by the static value. It is a method that returns a list of type integers. insert sort. So we're going to have a list of integers. Insert sort is the name. Final. So those parameters the value of which cannot be changed, or that's odd. Why are they declared final? That I don't know. I don't know why those are constants. List. It's a list of numbers that is declared as a type that cannot be changed, or something value. Yeah, something about that. It's a list of type integers. Right. Final list. Integer. Yeah. Sorted list. A new linked list. It's a new linked list named sorted for list integers. You're creating space and memory for this element, this object. Sorted list. It's a list of type integers. It too is going to be final. I don't understand why they're final. Original list. Original list for variables. List 1, or what we were calling L, and sorted list is NL, basically. So for each one of the original number list, or whatever it is, they're just giving it the name number for each of the elements in that array. Yes, you take and you are assigning it to a variable. Original list, right? You're assigning it. Original list. You're performing a for. Oh no, you're returning it. Are you returning? Integer number and numbers. Original list. Where does original list come from here? Original list. 4. Okay, so I got to figure out what if. No, this value is coming from somewhere else, right? Like you got an original list somewhere, and then you get numbers from this right here. Original list, but I don't see how original list is in the code. Yeah, that's odd for me right there. I don't quite get that. For some numbers, for each one of those numbers, for the sorted list dot size, for the size of that array, sorted list dot get. Yeah, you're getting that position of sorted. You're getting that value from a sorted list. And right now that sorted list is empty, right? So then you're adding, at that position, you're adding that number. And you're adding it there. The sorting is taking place, the repositioning of each of those elements. Let's say you're adding something at this index here, then x plus 1 to x plus n all get pushed over 1. They get moved over by the algorithm. All of these. Add that there. What was here gets put over here, and what was here gets put over here, all the way down the line. That's what's being done inside of here. for the original list. So I would say that I just don't see why this is inside of the. It may be declared outside of it, and then it's used. It's referenced from the inside. That's the first guess that I have as to the Java syntax that I don't quite get here. Or this is what gets returned. Sorted list. Original list is a reference from somewhere else. Or yeah, it's not. Continue with original list. Here's how it's used here. Integer numbers. I don't see why it has a new, like a alias or something like that. Like, why can't you just use the 4? And I don't know if alias is the right word for it. So armed with a fresh set of questions, I go back into my text. Because there's a lot about, I just ripped the code off. But you see what we're doing each time, even when we're learning. We're not just writing down what the other person wrote down, right? We're running around those loops and encountering issues, problems, and doing the research to understand what the text might say in the next position. And this is the best way to learn, because you actually are reproducing the problem, or you're starting to realize why things are the way that they are. And that's funny, because actually, and maybe I'll do this in the future, so I skipped straight to bubble sort to feed the beast, but actually the book starts out talking about the difference between comparable and comparator interfaces, right? Which I didn't want to start with, because what does that mean to people that haven't seen how those things are used? Especially since I'm trying to kind of pull you in like a black hole, you know, suck you in and change your life. Alright, so we're talking to everybody. Alright, the method returns a new list unlike the bubble sort, which sorted the elements in place. That's mainly the choice of the implementation. So linked list instance. A linked list is very efficient in adding elements in the middle of the list by rearranging the pointers of the nodes of the list. If an array list had been used, if an array list had been used, adding elements to the middle would have been expensive. An array list is backed by an array, so inserting at the front or middle of the list means that all subsequent elements must be shifted along by one to a new slot in the array. This can be very expensive if you have a list with several million rows, especially if you are inserting early in the list. So these were all the challenges that we were faced with the array, and trying to handle and realizing the cost of them. Finally, the outer loop in the implementation is labeled original list. Okay, it's just labeled original list. You can apparently label, can you label loops in Java? So in JavaScript, you can give labels to certain structure type loops and ifs and certain structure types or work control structures, structures that control the flow of the program. They can be assigned a name, and it looks like you can do the same thing in Java. So naming for loop, Java, right? The labeled statement is what it's called. Java provides a feature not very frequently used called the labeled statement. So yeah, it's a bit of pedantic floral work. You're not going to see labeled for loops that much, right? So this slate right here was just a label. It's just a label for a for loop. Labeled for loop, right? And so that, I think, accounts for everything. And so that's just it. So, and this gets into the heart of what why when I say you can be a keyboardist, right? Or you can be a musician, but you have to choose an instrument, right? You can be a musician, but you also need to be a keyboardist or a guitarist or a singer. You know, there's not that many D'Angelos running around out here. You need to know for the interviews, if you're going to a Java interview, then you need to be able to implement these classical algorithms in that particular language. And each language is going to have some different syntactical rules that you need to know, such as what you're seeing right here, a labeled for loop, or like the way that this value, sorted lists value, is pulled here using the .get method, which comes with the linked list class, and then how add works, that it performs what was described as an expensive operation of shifting every element, subsequent element, over one, even if you have millions of elements. So that goes back to what we were starting off with, is how does insert sort work? Yeah, and then every time you watch these videos, you're probably gonna have that moment, if you're watching, where I'm gonna realize what's happened and what we just did, and that's just now. Yeah, student of the Dow, doing it now, punching the pow, Mario style, clearing the board, cut your mic cord, man. Like, in this very moment, there's a mini Satori. And I guess I could throw in some of what I know, right? Because I should throw in some of the Enlightenment talk, code of the streets. I have to wake you up. So then you have so you then have a little mini Satori, a moment of enlightenment, an explosion in the mind where the world is not the same. Insert sort involves two collections, and you check for every element in collection 1. We're going to check collection 2, and we're going to check each element in collection 2 against the first, second, third, nth element in collection 1. We perform the loop on the inside. We go over the element in each element in collection 2 until we finish checking each of those against 1, and then we go to the next one and 1. And for each one of those iterations, we're checking to see if the element in the original is less than the element in the second one. So here, I may see this in my head, but I'm supposed to be presenting a model to you. But this is now what I understand, is what we insert sort is and how we're using it. Or I understand most of it. There may be the 5% left that I don't get, but we're there now. And notice each time I draw these models, it's slightly different, right? Because you're creating models to model the problem, whatever that problem is. Maybe presenting information to an audience, or solving the problem for yourself, but you're creating models. Get used to creating models. It's the best way. It's the only way. It is the way. Way, hey, spray. I got a million of them. I can sing anything. You'll give me a song, I can sing it. Tony Clifton. Alright. So we have these elements. Let's see. 8, 6, 5, 9, 4, 2, 7, 3, 1, 0. Maybe I used them all. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I did. Alright, so for the algorithm, numbers coming from the original list. We're starting right here. If number is less than 6, it's not. So then it's just going to go to the next item. The loop is going to go. Is number less than, is 8 less than 9? Yes, 8 is less than 9. Then the algorithm is going to take 8. Oh, okay. That is funny. Alright. So just by starting over again, it kind of gave me a different idea. Because you see, I'm using an array-like structure and an array-like illustration. But in reality, this isn't using arrays. It's not. It's using a collection of objects. It's using something we already did, which is kind of show a collection of objects. This is a list of integers. You have in Java you have 2 types of integers. You have integers that are of primitive type, and then you have integers that are wrapped in class objects. Right? So we would be better off representing our list as this. And that makes a difference because a list and an array are 2 completely separate concepts. Right. I don't know what my values were. 8, 6. I really don't remember. 5, 2, 0, 9. 1, 3, 7, 4. There you go. So earlier we were going to insert 8 somewhere, but now whatever it is that we're inserting, let's go over it again, is 8 less than 6, where we're getting the value, first iteration inside this inner loop, I is equal to 0, is 8 less than 6, and number is equal to the first number in the numbers array. This is the numbers array right here. Each one of these will be put in the value of number. Is 8 less than position 0, 6. No. So then we're just going. So then this if statement, we just go back. I goes to 1 is 8. I goes to 1 less than 1. No. So for all of these, we continue until there's nothing, and then that if statement, that if there was nothing to switch, then you add to the end. That's taken care of by this right here, because we go through this entire loop for this value, and there's nowhere to add it. We're still in the big for loop for the entire collection for numbers. But before we leave, we're going to add that. Otherwise, we would have already added it. To the list. Right, and we would have continued to the next number. So to make sure we wouldn't have added it at the end, we would have just gone to the next one. Continued the original list, which is the label for. So what you're learning, what I just learned, is that the reason we might want to give that for, this fancy for, a name is because we can then call it with a continue statement inside the loop and push it forward in its iteration, which is a good tool to have for those fours, for those fancy fours. I don't think you can do that in JavaScript, or maybe you can, I just didn't know. That's a pretty dope trick, right? Alright, and so now actually I'll come to the place where I actually understand what the code is doing then. Right, so we're just adding. Usually, a lot of times, to address the last position of an array, we do array.size or list.size -1. But here, we're doing .size, which causes us to add the position to that value, which is 1, 2, 3, 4, 5. But we're adding it, we're taking 5, and we're using that as the value of the index, because this is what this method takes, is that position, the index position you wish to add the value to, and we're adding that number. So we added 8 to what is the index position equal to the size of the array, which actually puts a new element on, when I say array, of the list. So we're adding that to the list. Yeah. So I actually think, and so then, because this for loop is done, this is the if, this is the for, that for loop has, the inner for loop has just completed a go, and that's why you're here, but you're still on the inner loop. So wait a minute. Yeah. And yeah. Okay. If nothing, and then you're still on that, in that 4, right, so then, alright, that's a little bit, 4, if nothing, so then, boom, over here, continue original list. Okay, otherwise, right? let's say we don't say continue original list. Then nothing was, you're adding that to the end. Right. It's still in, okay, so then you're starting again. Here, you have to start the inner loop again. And you gotta start it coming to the very beginning again. Yes. Yes. So you gotta start it coming to the very beginning again and going through all of these, including the additional element. You're not done checking 6. Right, so if 5 is less than 6, right, so here, the first time, 8 got added to the back. And that's an example of if there's nothing to choose. Or if 8 is larger than every other element that it had come across, then we add it to the back. But here is an example where 5, the next element, is less than 6. So if 5 is less than 6 of what we're getting, which is starting again at 0, because we went through everything for 8. And now we added 8 to the end, and then we're back in again. And we're reinitializing this, starting at 0. Right. But we're doing it for 5, so we're starting from here again. 5. If 5 is less than the value at index I, or 0 again, then we're going to add at position, at index, at sorted add, we're going to add the value number 5. We're going to add that here. And that add not only involves, that's the hard part, is that that add not only involves just putting that value of 5 in there, but all subsequent actions that Java is going to do. Because what Java is going to do is it's going to add 5 here in this position. And then it's going to move 6 here. It's going to move 1. It's going to move 1 here. It's going to move 7 here. All the way down the line. It's going to do all of that. So this is at 0. And 6, which was at 0, is now at 1. And 1, which was at 1, is now at 2. And 7, which was at 2, is now at 3. It's moving each one of those elements over using some kind of temporary storage that you never see. And a variable that we don't declare. It's moving things around behind the scenes in storage, so that you can just call add at that position, and it's doing all this work of moving this entire array, or not array, of this collection to those index positions in memory. And then, instead of going to the next value here, 5 and 1, no, it's done. It continues that original list. So it goes to 2, and it's going to ask a question. It goes to the next element of the original list, and that inner for loop gets reset. It's back to 0. So it's comparing these two, and it's asking, is 2 less than sorted list? Oh, okay. Oh. No, that's right. No, that's right. It's not a sorted list in the beginning. It doesn't have to be. It's going to be a sorted list in the end because the elements are being put in. Into sorted position. Is that accurate? So that's one of the questions. Does the list have to be, does the sorted list already need to be sorted that we are looking at? And oh, look at that, and look at that, and look at that, right. So we made a couple errors. Yep, and this is the process, and this is the way. This is the process. So we're learning some great things about this algorithm and how it puts elements in. In this implementation, we're putting elements in the right positions, but we missed something. And what we missed was that the sorted list is a new linked list that has 0 values, but like we talked about earlier, Java initializes a list to null values. So really, what we're doing is we're going to sort this list. That has nothing in it at first. It has a size equal to 0. And what's in this position? Nothing. 0. So if sorted list doesn't have to equal a new linked list. It could equal the value of a sorted list. You could start it out with a collection of elements that was already sorted. And the reason we had to erase what we had is because our collection was not sorted. Right. So we could have anything in here. We could have 1, 4, 6, 7, 9. As long as the value, so insert sort. Now we're getting to the heart of it. Now we're actually learning what insert sort is. And this is what is interesting about, I think, what I'm trying to do here. One is reveal the process of becoming a developer, and 2, these little stories that a person has as they learn something. It's applicable to larger learning. So there's a reason that variable is named sorted list, not because it creates a sorted list, but also because what gets added to it, you can either start with an empty list, in which case you got null values, 0 values, or you start with a sorted list. And that sorted list, then we can go through and add elements through our unsorted collection of numbers. We can add it to a sorted list. So what are the rules of insert sort? We're starting to piece this together, is that you have 2 collections, 2 lists. One of those lists, the one that you're going to add values to, is already sorted. And what you're going to do is you're going to check the value of the unsorted number against the value of the sorted elements, and you're going to say, for this position, is 8 less than 1? No. Is 8 less than 4? No. Is 8 less than 6? No. Is 8 less than 7? No. Is 8 less than 9? Yes. If 8 is less than 9...
Do you think it'd be available for us to give some money to be around somewhere?
We're going to add 8 to this position and shift everything to the left over one index position added after, right? So 8's going in there. Right, and then we're going to the next list. We're going to the next item in the list. Is 5 less than 1? No. Is 5 less than 4? No. Is 5 less than 6? Yes. So we're going to add 5 in that position. And then behind the scenes, we're going to shift 0, 1, 2, 3, 4, 5. So the new list, 5 is going to be at index 2. 1, 4, 5, 6, 7, 8, 9. 6. So one of the requirements for insert sort to work is that of the two collections, one of them is already sorted, and the unsorted element, you compare the elements, each element in the unsorted collection with each position of the sorted collection. If you see a position where the element in the sorted collection is greater than the element you're checking for, then you put that element that you're checking for, you add it to the position of the element that is greater, and everything else is taken care of by Java of moving the element, each element, subsequent element, down one index position in storage in memory. And that is how insert sort works. Yeah, that's how insert sort works. So that took me 2 hours and 17 minutes. Yeah. And I have a whole different understanding of Java. And actually part of the time was bubble sort. Yeah, rewriting bubble sort. So the continue statement associated with the for statement, I'm going to take that away from me. I'm going to take that away. One thing I don't understand is the use of final here. So I'm just going to have to memorize that if I'm writing this, because in the whiteboarding interview you got to write the stuff in the language of that you have chosen to use. So you're going to have to also gain an understanding of why final is used there. Well, what final is used for, right? You're making you're locking in the inheritance of the rules of inheritance for any other subsequent methods, fields, or classes, right? So here you're making it final that you take type list integer, I guess. Yeah, I mean, I guess it's just for Java purposes. I don't know if that's even necessary. I don't know why it's necessary. Yeah. Alright. List integer, sorted list, new, linked list. On generic type, you don't have to put the other generic type in there, but you could write integer again right here. Right, but you don't have to. The compiler takes care of that. Original list, you're given the label for the labeled for loop. For integer number, numbers, for int I, sorted list dot size, right? Not -1 dot size, int I. Sorted list dot size is less than sorted list dot size. That's interesting. Less than sorted list dot size. No -1. I don't know why for sorted list dot size. I guess because no, I really don't know. I don't know why it's not -1 sorted list dot size. I don't know why it's not minus. It is sorted list dot size. All right. The algorithm described here uses twice as much space to sort the list because a new list is returned. Okay. I mean, there's some more parts of this that I would benefit from understanding, just a little. But you are never going to master every aspect of it all. What you can do is start the memorization process. I think everything down here checks out where it makes sense, including the mental process of splitting this into little rectangles as opposed to keeping it stored in the concept of array, like an array type box. It's important for your mental models and for your brain. Your brain is a powerful tool. It is photographing every bit of this, locking it in a way you can't even fathom. Right? You don't know how you memorize things, you just choose to do so, correct? The rest is taken care of by your OS. Right. Alright, so somehow I have to memorize this, and that's where we are now in this particular situation. So what we do is we track our steps, right? This is a lot less code than I had to do last week, and I'm going to check against what I write here. I'm going to check it against what I have on my phone, plus I'm going to track the work I did here with the collections, the collection model, the model of the collection. That's another thing. You still should hear me say the same thing 3 times, 3 different ways, right? But I'll try to pinpoint the language. Being specific with your language is an important part of being a developer. There's no way around it. So now that we have that tracked, we can check against it. We look at our phone. This is the hard part, because I didn't try to memorize anything. Alright. And the question becomes, how much, it quickly switches from a problem involving completely language agnostic and speaking about the problem of insertion sort and adding values to a collection, and we quickly go through that to understanding what the problem is in the first place and how the implementation is handled, whether we're dealing with arrays or we're dealing with a programming language and its implementation, and how it behind the scenes performs certain algorithmic calculations, and then also the methods of the list elements. See, if you're coming from JavaScript, some of these things don't exist. You don't have like list classes that you have arrays that can hold any sort of value regardless, right? It doesn't matter what the type is. They're also implemented in there is the concept of generics. So you really need to look at those. I'm going to show you something. Try not to completely destroy my setup in the process. I guess in at least once every video I'm going to do something clumsy. That's cool with me. You know what I'm saying? I still got the you don't know what you're talking to. Cope with the streets. Cope with the streets. So this text, Java generics, this is gonna, I read the first chapter, and actually this is what's interesting to me, is that I didn't prep for this video knowing that I needed to understand generics or feel comfortable with that syntax, but I read this chapter, the first chapter in that, in between in the past week, yeah, and that actually applied to what we did today. And that's part of the other lesson that I have to say. The people are going to tell you all times, always be coding. No, always be learning, right? And some of that learning is going to be coding, and some of it's going to be reading syntax that you've never seen before. And why is that important? Because when you encounter it, it makes it so much easier. If I hadn't read that information, when I'm looking at this, I'm just not going to be as comfortable as when I realized that what got added to Java was the concept of defining the types of lists. Because in Java, let's say you create a dog class, then you could have a list of type dog, right? Or you could have lists of type integers. This is just defining what that list is. That's it. It's pretty simple. But if you don't know, when you approach that syntax, it's going to look crazy. Right? Or what I just learned was that if I saw a list of type T or a list of type E, this is wholly arbitrary what value you put in there. But there are, the language has like preferred syntax referencing different things, types or elements. And you know what that means specifically, I don't know. I read it. It's a common thing. You read something, you get an understanding of it, and then you have a vague understanding of what it means. And you have to go over it and over it and over it and over it until it becomes something that you can recite. But even that awareness is useful. T may as well be dog. It doesn't matter. Matters to you in making the code legible to you and other developers that will use that code. So I really don't even remember I don't have the slightest clue, because I didn't write that code with the goal of memorization. But let's see what we have here. I remember that I asked why that word final was there. I know that I have static in there. I think it's a list of type integer. I remember now that it's more code than I was hoping. It's gonna be, that's what that's returning. I do think that we are using a method of type insert sort. I think that this was final too. List integer. And then this may have had a name. Numbers. Right? That's actually pretty close. And then there's the curly brace. Excuse my running out of space. Right? So we try to do things neat around here. So let's rewrite that. Because we do try to do things neat around here. If you were on a whiteboard interview, it would be a good thing to rewrite that. Final static list integer insert sort. Insert sort, and then I have final list. Oh yeah. Yeah, see I'm not, yeah, no, this is probably right. Integer. Numbers. Boom. Right? Really erase. Boom. And then yes. Okay, so then on the inside we have final. I do not know what that was. It was just final. It was list. Integer. Sorted list. Let's assign the value of new list. Linked list. Yeah. Is this a linked list? This may have been a linked list. This may have been a linked list, which explains the behind the scenes processes. Sorted list. New. I don't know why I remember linked list here. I just remember that there were these double arrows, and that's the implementation, and that you don't need to have integer in both spaces for a new linked list. Sorted list, and this is the syntax. And then I think I have original list. I have here, I have 4, and then in that 4, I have, it's the fancy syntax for 4. Numbers, something to that effect, right? So we're iterating over the numbers, and for each one, we're putting that value in a variable we're going to use in the nested for loop. And in that for, we're going to declare a looping variable I and assign it the value of 0. I is less than sorted list dot size. You know, I think we call it too, which is no. I keep asking that question, and I don't think that is true. Sorted list dot size I plus plus, and then there's if number is less than sorted list dot get I. If number is less than sorted list dot get I, if the value of the collection up here is less of this value for each one of these, yeah. Sorted list dot size, for sorted list dot size. If this I, yeah. The first one for this particular one, if number is less, then we're going to add, then if that's true, then sorted list dot add. And what are we adding? The value, it's probably like number and the value at I don't know. Yeah, that's tough. Number to the value at I don't know. And it's going to handle all those operations of moving all those elements and continue. Yeah. Continue on original list. Right. Otherwise, right, that's the end of that 4. We're going to add to the end. Otherwise, that's why the variation sorted list dot add. Okay, so it's probably the other way, I and number. I think it's like sorted list dot size and number. I don't know what these, I don't know. Yeah, I think that might be right. I don't know the syntax of the add function for a list, for a linked list. Yeah. So there you go. So there's something to take away, is that I don't know the syntax for a get and add for a linked list. I don't have that code going in. So for me, something that would be good to look up is linked lists in JavaScript and implementing something using a linked list. Maybe implementing a linked list itself. I don't know. But I'm going to need to know that syntax and how to add elements to a linked list by heart. But there's no linked lists in JavaScript. So it's part of challenge, right? You're learning a new language, you're learning new syntax, you learn new ways to write code, and makes you on steroids, bro. Bruh. Do you even lift, bro? Alright, so then we have that. I'm gonna say this is the end of the original 4 underneath here. And the thing that they were saying was expensive, I think, was the operation of at the end of each, and this is the little bit that I don't still understand about the return the sorted list, is how many times. I think that may be true, is that we're returning the sorted list. Now, that, once again, bro, I'm telling you, even if that's completely wrong, and it can't be completely wrong, I memorized a great deal of goddamn information right there. You know, and it's, I mean, I have a pretty good memory. I do. You know, when you're in a club at 2 a.m. and you've been drinking with your friends and you're performing songs in front of 50 people, like, let's just say I usually remembered most of my songs. I mean, like, it was pretty good. It's the kid. But, I still think the combination of the pen and the hand and the mind and the body helps reinforce it so much more than if I were typing this into a computer. Plus, this is how you have to do it in the interviews. So repetition. I'm just going to reinforce that information. Sorry guys, this video went way longer than I imagined, but it's realistic. It's realistic, and look, it's approaching 3 hours. I mean, like, so this was the problem that I also faced in school, being tossed into an advanced algorithm course, where for the advanced algorithmic program for masters in computer science, they expected you to have all of this already done. Including the concept of sorting algorithms, all of it. We just hopped into time complexity, which is something that we'll talk about at some point. And more implementation of code than I had ever done in my life, and in the program. That was pretty tough. I wasn't ready, especially not with Java or as a programmer in general. You know, I'm not saying I won't go back to school. If I find the right scenario where it makes sense, then hell yeah, I'm in school again. This time with an awareness of what these challenges are and what I need to implement. You know, switching out my mugs. I had my old granny mug, you know what I mean, but now I'm Batman. So gotta represent my bat skills on this one. Just shut your mouth. Alright, so that looks pretty good. I don't know if that's actually accurate. I'll use the book right now, actually, instead of digging through my phone. And see how close we got to the actual code. Public static list integer, insert sort, final list and enter numbers, final. It wasn't a linked list, it was a list. Sorted list. Oh, okay, yeah, it was. It was a linked list over here. Over here, it was just a list element, which makes sense. List, linked list must inherit from list. I have original list 4. This should have been declared as an integer object. Or as an object of type integer. Integer number numbers for an I sorted list dot size. It actually is called. Alright, so then last time with dot length in Java we didn't, but dot size I guess we do, because maybe this of the type, whatever, maybe the size is something different than what some more syntax that I have to uncover here, but I don't think now is a particular time to do it. I++ if number is less than sorted list dot get I, sorted list dot add I, get a common number, continue original list, sorted list dot add, sorted list dot size, once again that value. So what I'm wondering about is dot length was a property of something. So you didn't call it as a method. Dot size, you're calling it as a method because it's a method of the class instance, the sorted list. Right, so that's how that value is being supplied. Alright, so here, size, comma, number, right, and single space, return sorted list, single space, single curly brace, return sorted list, single curly brace. So that's pretty good. That's pretty good. List integer. This is inheriting from the list, and the integer type here for number. But I got this syntax right. I got this syntax, final static, original list for numbers. Just remember size, and I got this correct, that the index position is being determined here. The add takes 2 elements, maybe 3, I don't know, arguments, but it takes index and the value of the number. I mean, you gotta say that's pretty rock solid. So if I'm going to follow my rules, which I should, you know, a good teacher would follow his own goddamn laws. I'm not going to ask you to do as I say and not as I do. Then I'm going to rewrite that. Because the idea is muscle memory. Final static list. And I still don't have it. I still don't have it right. Final static list integer. Insert sort. Final list integer numbers. Right? Then I have final list integer new linked list. Yeah. You don't want to make any dumb mistakes, right? Sorted list. So in the whiteboarding, you know, you don't want to make any dumb mistakes. That'll cost you between you and the kid that went to Yale. like that's what they're choosing between there. We're gonna choose Tyrone. You know, it's just something about him. I like him. So that doesn't need to be there. It can be. Doesn't need to be. You might explain that in the interview. Get yourself a little points. New linked list. Alright, sorted list, new linked list. And then we're gonna name the labeled for loop original list for integer, the number variable in the numbers array, for int I, so 0 I is less than stored list dot size I gets incremented, for if number is less than stored list dot get I, right? If number is less than stored list dot get I, if for that collection here, if this value is less than this one, then we're gonna add stored list dot add index number. And that's going to do all the work. And then continue. Original list. Continue the for loop. Continue the for loop. Let's close that off. Let's close this off. And then else stored list dot add stored list dot get I and number, and then one more for this, and then we return stored list. When does that get returned? Let's see if we clarified that point. When does stored list get returned? We add get number at the very end. We grow the list, right? And then we go back in for the next element in the collection of original list, right? That we're comparing against stored list. Yeah, because we're growing stored list. We're growing stored list. And each of those elements in the original list has to get added to stored list, right? Whether it's at the end or somewhere in the middle of the list, right? So we're returning stored list. We're returning it each time. I think that's what the text said, and now I think I'm getting there. Now this is the end. We're returning it once. A list integer, right? Duh. So this definitely is a method, right? We're returning it once. A list type integer stored list, which is also a type linked list, right? Right. So this only gets returned. I gotta look that up. I think this only gets returned once at the end. This is the end of if and inner for end of outer for and this is end of inner sort method. Insert sort, I'm sorry. Insert sort method. And I think that is about right. Let's check our source again. Public static list integer, insert sort final list integer, numbers, final list integer, sorted list new, linked list, correct syntax, original list for, integer number, numbers for, and I is list, sorted list dot size. Oh, hold on. So I'm gonna give myself a break. That is the wrong method. Right. We're not getting it. It's size. Right. Size I plus plus if number less than sorted list dot get I sorted list dot add I number continue original list into if inner for sorted list dot add sorted list dot size number into that return sorted list end of inserted sort method. Alright, so you know what? Let's not give ourselves a break. Let's man up out this mofo, huh? Right? You screwed up memorization, bro. You know, and at the end of the day, my competition is going to get that right because they've been in the room since the time they were 10 years old, being fed food and water and being taught that they need to write code, okay? They're not. It doesn't matter how much humanity they have, whether they're good people or not. Okay. So what I gotta do is do this again because I let my memory slack. 3 hours in, I'm a little tired, but you know what? If I was whiteboarding for Google, I'd have multiple interviews all day with harder algorithms and teams of people questioning my logic. Right? Well, I gotta work it out loud. So, you know what? Doing it in the comfort of my own home, it ain't bad. So, let's do this one more time. Or let's do it until we get it right. Final. Static. List. Integer. It's a method. We're creating call insert sort. Final. List. Integer. Numbers. Right. Final. Yes. List. Integer. Sorted list. New. Linked list. Right? Yes. Original list. 4. Integer number of the numbers array. 4. Int I. Int, no. Yeah, I'm definitely spacing now. Int I, where I is less than sorted list dot size I. If number is less than, if number is less than sorted list dot get I. And I keep trying to think of a swapping algorithm here, but that's not what we have to do. If that is true, this is how you use Java. You're going for Java jobs. If sorted list dot add I number. Add number to that index position and perform the rest of the manipulation of the list. And then original list. Continue. Continue with the original list. That's the end of that if statement. That's the end of that for. Because we're going to do that for each one of those elements in the two lists, right? And this also allows you to have lists of different sizes, actually, right? Because you're just going along the number, the list numbers, and for each one of the elements of the sorted list, right? Right. So then that's done. And if nothing was added into the middle of that collection, then sorted. Then we're going to add it at the end. Sorted list dot add sorted list dot size number. One more into the 4, big 4. Then we're returning from the method insert sort. We are returning sorted list, which is a sorted list type integer. And so, my friends, that's basically insert sort. And so what would I say insert sort is? That